And to finish out this little series of videos, we just have two small square root equations to solve. And you can tell that they are square root equations because the variable is inside the square root. So we can't really do anything until we get rid of these square roots. We can't start solving until we get rid of these square roots. So the first step is to isolate this entire square root. So in order to isolate the square root, we have to get rid of everything that's outside of the square root and on the same side of the equation, so this plus 10. So we just have to subtract 10 from both sides. It's a good place to start. That will turn into 0. And on the left, we have the square root of 3x equals x minus 6. Now that the square root is isolated, we can get rid of the square root by squaring both sides. And this means the entire side, parentheses around the x minus 6, gets squared. So this means when you are squaring this, it will be x minus 6 times x minus 6. You're squaring a binomial. On the left side, that's easy enough. The square and the square root reduce away. That's the whole point for squaring. So you have 3x equals x squared minus 12x plus 36 once you FOIL this out. So now you can see we have a quadratic equation, so we need an equals 0, so minus 3x from both sides, and this gives us the new equation 0 equals x squared minus 15x plus 36. Generally speaking, if you are working through a square root equation and you get something quadratic, it will factor. So here is how this factors. This turns into x minus 3 times x minus 12. Again, you can use your split b if that's what you like. You can do all those extra steps over here. I'm just trying to keep this video relatively short. And then now we can set each factor equal to 0. This gives us x equals 3 if you solve for x, and this one gives you x equals 12 if you solve for x. And you might think you're done, but with a square root equation, you must check your answers. Kind of like with the rational equations, with the variable in the denominator, there's a chance that you get a 0 in the denominator and you're not allowed to divide by 0. So there's also a chance here that the answers will not work. So what we do is for a check, we look back at the original equation, which is the square root of 3 times x, but we're not going to put x in there, we're going to put one of our answers in there, plus 10 equals x plus 4. So the first time around, I'm going to pick 3. And this is 3 times 3 is 9, so this becomes square root of 9 plus 10 equals 3 plus 4 is 7. The square root of 9 is 3 plus 10 equals 7. It looks like we're trying to get something here, 13 equals 7. That does not work. 13 does not equal 7, so that means 3 is not a good answer. Let's see what happens if we replace 3 with something else, the other answer. What happens if we replace 3 with 12? Let's see here. So 3 times 12 is 36, so this becomes square root of 36 plus 10 equals 12 plus 4 is 16. The square root of 36 is 6 plus 10 equals 16. Hey, 6 plus 10 does equal 16. So that means 12 is a good answer. When an answer doesn't work, we call it extraneous. So x equals 3 here is an extraneous solution, or an extraneous answer. So over here in this right example, we're going to try to do something very, very similar. So here you can see there's the square root. And there is something on the left side of the equation outside of the square root. It's that -2. So in order to isolate the square root, we need to add 2 to both sides. This zeroes out, and that gives you a new equation. 4k plus 5 inside the square root equals 2k minus 5. And again, now that the square root is isolated, we can square both sides, the entire side. Again, this means that you will be multiplying 2k minus 5 times 2k minus 5. And on the left side, of course, the square and the square root will reduce away, leaving you with a 4k plus 5 on the left and a 4k squared minus 20k plus 25 on the right. So again, this is quadratic. You need to get all the terms over here, so we have an equal 0. So subtract 4k, that will become 0. Subtract 4k. Subtract 5, that will become 0. Subtract 5. So you're left with 0 equals 4k squared minus 24k minus 20. This should be plus 20 right here. So now you might notice that all of these numbers are divisible by 4. And again, we can divide an entire equation by a number. We can't divide an entire equation by a variable. So we can rewrite this equation to be much nicer, to be 0 equals k squared minus 6k plus 5. And this gives us the factors k minus 5 and k minus 1. And if you set each of these equal to 0 and solve for k, you'll get k equals 5 and k equals 1. Now that we have two answers, we need to check. And that's pretty easy. You can just go back to the original equation. This is the square root of 4 times something plus 5, all inside the square root minus 2, equals 2 times something minus 7. And you can pick either answer to start with. I'm going to start with k equals 5. So I'm going to put a 5 here and a 5 here. And we're just going to simplify this left and right to see if we get the same thing on both sides of the equations. If we get the same thing, it's a good answer. So 4 times 5 is 20, plus 5 is 25, so this becomes square root of 25 minus 2 equals 2 times 5 is 10 minus 7. The square root of 25 is 5 minus 2 equals 10 minus 7. When you look here, 5 minus 2 is 3. This equals 10 minus 7 is 3. Oh, great. We got the same thing. This is a good answer. So now we can go back and we can check out what happens if we substitute the 1 in there for k. Let me erase all this. There we go. So we will have 4 times 1 plus 5 minus 2 equals 2 times 1 minus 7. So 4 times 1 plus 5 is 9. So square root of 9 minus 2 equals 2 times 1 is 2 minus 7. The square root of 9 is 3 minus 2 equals negative 5. So 1 equals negative 5. That does not work. So k equals 1 in this case is what we would say is extraneous. And it doesn't work. And our only answer here is k equals 5.